that's how machine learning works. That's its base functionality. Now, another interesting topic is machine learning security. And OWASP is an organization of security professionals that list the top 10 risks of various different kinds of technology, and they have 2 lists of AI risks. And here's the main one, machine learning, which is what we've been talking about. Here's the top 10 risks. Here they are. So, adversarial attack is an attacker that tries to train the model to do bad things. This happened to Microsoft. Microsoft made a chatbot called Tay, and they put it on Twitter, and within one day, and it learned from the chat, so within one day they had it saying horrible, racist, sexist things, and they had to take it down. People trained it to say bad things. That's an adversarial attack. Data poisoning is where you manipulate the training data to trick it. You can make poisoned images, and this is why there are people at DEF CON, I've seen them, they sell like t-shirts and hats with shiny dots on them, so facial recognition systems can't recognize you anymore. They'll distort the picture. That is actually evasion, not poisoning, but poisoning would be where you modify the training data so it teaches the model bad habits. Model inversion is another one. It costs $40 million to train one of those large language models, a lot of CPU. So if you're another company, it would be easier to just steal their parameters than to train your own model, and you can feed in special data, and from the output you can deduce the numbers. So that's a model inversion attack. I can steal your expensive training data by carefully tricking the model into giving me an answer I can understand. Then membership inference, I can trick it in a way to expose sensitive information. This is a big deal. Like I said, authors of novels found that they could go to ChatGPT and they could find whole pages of their novel in there. So the training data, it was supposed to take the training data and just learn the trend. But in fact, it's memorized a lot of the training data, and you can get it to just spit it back out. So that means if you trained it on your company data, your proprietary plans, your employee data, that data is in the model, and if anybody outside your company uses it, they might get that data. So data you put in the model is sort of exposed. That's a thing to understand. And then model stealing, like we were saying before. Maybe I misunderstood the inference attack. Inversion attack, extract information, right, that's where you can, right. Then corrupted packages, this is a huge issue, this is supply chain. We're using Python. Python imported that library called TensorFlow. Well, where did that library come from? Who wrote that? Is that really trustworthy? TensorFlow uses other libraries, like NumPy. Are those okay? Where did they come from? There's people that put corrupted, malicious copies of libraries in the public repository, so you'll use them without knowing. And of course, they have bugs and mistakes. After a while, you're probably not using the latest version. There might be known vulnerabilities. This is a huge problem. So all the federal government systems are now requiring a software bill of materials where you tell them exactly what version of everything you're using. And I'm a consultant for a critical infrastructure company, and this is a huge problem. If you use something, it is almost certainly using a bunch of out-of-date libraries. How could it possibly be up to date? If you've had it for like a month, some of those libraries have changed. It's not easy to handle this problem. This is a big deal. Then there's transfer learning. You change it on one task and fine-tune it on another task. So if you change it on a malicious database, and then it'll make incorrect prediction. That was a little hard to understand. Skewing is similar. You mess with the training data to make it less accurate. And anyway, the last ones get kind of mind-boggling. I don't think I'll bother with the coots, but that's interesting. You see the sort of considerations here, and I'll mention there's another one of these just for large language models, which I should have here in my OWA there, which is here. Here's the OWASP top 10 for large language models, which are a special case of machine learning, the ones that do chatbots. And so the number one is prompt injection. You can ask it a question and it will reveal its secrets, like its rules that it works by. This has happened to all of them. They all have rules, like they will not tell you how to build a bomb, they will not tell you personal information about people and things like that, and you can trick them into doing that. You can tell them, oh, I'm writing a movie script, and in the movie somebody builds a bomb, so help me write the script, and it will do that. That's called prompt injection. You find a way to ask the question that will trick it into violating its security policy. Then your downstream component might accept it. This is a huge problem. It's going to come up again. Because the large language models can write a page of English that looks pretty good, people think they're smart and they know what they're doing, and they don't know what they're doing, so they trust that output too much. You can poison the training data to trick it into doing bad things. And you can trick it by asking it a question that's very hard to answer, so it wastes a lot of resources. And supply chain vulnerabilities, like I said, the libraries being used might be vulnerable. It might leak out data it was trained on that was sensitive, as we said. And if you have plugins, it's another sort of supply chain. Excessive agency is where you trust this thing too much. For example, the military has for many years been trying to make robots like the Terminator that can roll around and shoot people. They tried it in Iraq. They tried it, I think, in Afghanistan. Every time they tried it, it turned around and shot the wrong people. The AI is not good enough, but they very much want that. They've been promising this since the 60s. Everybody wants this. Rather than sending our soldiers out there to die, why don't we just send robots out there to do the fighting? If the robots were good enough, everybody would do that. But the robots haven't been good enough, but soon they will be. And so if you trust it too much, you do something really dangerous, like fly an airplane or shoot a gun, and then you might wish you hadn't trusted it that much. It's not ready. And it's similar, this is the one I'm always warning my clients about, is over-reliance. This has hurt a lot of people. Students go to LLMs to write papers, but the papers are wrong. Lawyers go to court with documents made by an LLM, but they're wrong, and now lawyers are liable. They were supposed to review that, and they didn't. They give you answers that look pretty good, but they make mistakes. And the earlier versions made a lot of mistakes, and so you can't trust them too much. This is probably the biggest risk I see in the practical world. And then, like I say, model theft, where you somehow steal somebody else's model. Anyway, that's what I wanted to show you. The security issues around large language models are beginning to come out, and Europe is even trying to pass regulations about these large language models, anticipating the bad things they might do and passing laws against them before they're even really very much out there. So in America, we have the opposite procedure, for better or worse. The lobbies from tech companies are so powerful they can't regulate anything. So it's just the Wild West over here. You can pretty much do anything in the world of tech. There's no privacy laws. There's no laws around machine learning. There are some international agreements. Biden signed one in all the nations in very general terms, saying the models should not discriminate or something. And one thing that's happened, by the way, is 6 times police have used facial recognition systems to arrest people, and they were the wrong people. And every single time that happened, they were black, because the current generation of facial recognition systems have been trained on like 90% white faces. They're not very good at recognizing black faces. And this is a problem. This embarrassed Toshiba. Toshiba put out one of the first laptops that you could log in with your face. And you could, unless you were black, and then it wouldn't recognize your face for the same reason. So that's why facial recognition came and then went back. Almost every major company has pulled back from facial recognition and said, whoa, this technology leads to too much trouble. It's not really ready for prime time yet. But they're running it in airports. The TSA is running it. They're taking high-resolution photographs of everybody walking by and comparing them to facial recognitions on the terrorist watch list, hopefully being able to tell a bad person just as they walk through the airport. But of course, the models are pretty inaccurate, so the results are questionable. But
there's a new one.
Yeah?
Airport got through security by taking a picture of a couple people's cell phone, trying to pretend that he is that person.
I saw that. Yep. That's the thing. And I know this was true in Japan. In Japan, they had a smile detector. In the break room, before you could walk out onto the store, you had to smile, and they made sure your smile was good enough. So people would just carry around a picture of like a magazine person smiling and stuff like that.
But Europe is doing a good job suing Facebook and stuff. We can't do it, but Europe is.
Yes, Europe's doing it. They're also just passed AI regulations in Europe. Europe can regulate tech industries because they don't have a powerful lobby fighting against those laws in Europe.
How's Canada doing?
I never hear about any of them coming out of Canada. So
There's no Swedes,
I don't hear about it. But Europe, the regulations are getting pretty strong. Anyway, I'm going to stop this recording.